Alright, so the very first question that we're going to see in examination when we're writing mathematics paper 1 is solve for x, but there's this first question that is going to ask you to factorize. Well, not really ask you to factorize, but it is going to need you to apply factorization for you to be able to apply this identity factor, right? So that is what we're going to be doing for this video. We're going to be checking factorizability. So we're going to check if a certain trinomial or whatever the case may be, a polynomial expression is factorizable or not. So how are we going about doing that? Well, we're going to look at what we call a discriminant. What is a discriminant? Discriminant is what you see in the quadratic formula. That b squared minus 4ac is what we call the discriminant. So it has roots and it also has rows, okay? So the discriminant is that thing that you see inside the square root, which is, we call it the delta, and it is b squared minus 4ac, right? So the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. This is the quadratic formula, right? So this quadratic formula has inside the square root or under the square root b squared minus 4ac. This b squared minus 4ac, whatever the value of this is, must not be less than 0, because if it is less than 0, then we're going to have a square root of a negative number, and you know that this is not real, okay? So that means that the roots are going to be non-real, and we're not going to have any roots at all, okay? Right, so we actually have to avoid this being negative. So this must not be negative. In fact, it must be positive. But it being positive, it must not be just a positive value. It must be a perfect square. So for us to say that an expression is factorizable, then its discriminant has to be equal to 0 or equal to a perfect square. For example, let us take x squared minus 7x plus 12. Let us take this expression. Is this expression factorizable or not? Let us say, for example, given something like this, x squared minus 7x plus 12 is equal to 0. That is the first question that we're going to see in examination, right? So we're going to need to factorize this. We don't want to utilize the quadratic formula. We're going to need to factorize this. So how do we know that we can actually factorize this? Before we even factorize it, how do we know that it can be factorized? Because if it cannot be factorized, then we have to utilize the quadratic formula. Even if it is factorizable, you're also welcome to utilize the quadratic formula. But I promise you that it is always convenient and satisfying when you know how to factorize, and just factorize because it is also simpler and quicker, okay? Right. So let us check if this can be factorized or not. That is what the purpose of this video is for. To teach you how to check if an equation or an expression is factorizable or not. So let us check if x squared minus 7x plus 12 is factorizable. So what you're going to do is say the discriminant, which is equal to b squared minus 4ac, is equal to, then we're going to identify the values of a, b, and c. So we can clearly see that a here is equal to 1, so a is equal to 1, b is negative 7, so b is equal to negative 7, c is positive 12, so c is equal to positive 12. So we're just going to substitute the values of a, b, and c into this discriminant and say b is negative 7, so negative 7 squared minus 4 into a, which is 1, multiplied by 12, which is, multiplied c, which is positive 12. Now we're going to say negative 7 squared, even if you press it into the calculator, you're going to get positive 49. And then we're going to say negative 4 multiplied 1 is negative 4, negative 4 multiplied 12 is negative 48. Now 49 minus 48 is 1. So now the discriminant is equal to 1. We have to ask ourselves, is this discriminant equal to 0? No, it is not equal to 0. But is it equal to a perfect square? Yes, it is equal to a perfect square, because 1 is a perfect square. So the fact that this discriminant is equal to a perfect square means that this expression can be factorized. So this is how we check if an expression can be factorized or not. So it can only be factorized if the discriminant is equal to 0 or if the discriminant is equal to a perfect square. This is the only time that we can tell if an expression is factorizable or not. If it is equal to 0 or equal to perfect square, it can be factorized. If not equal to either of this, then that means that it cannot be factorized. I hope that is clear. Let us go to the second example. So let us say that we have something like m squared minus 5m plus 6. Let us check if this one can be factorized. So we're going to say the discriminant is equal to b squared minus 4ac is equal to, and then we're going to say a is equal to 1, as you can clearly see, b is equal to negative 5, c is equal to positive 6. So we're going to say b, which is equal to this, which is negative 5, and then squared, minus 4 into a, which is 1, multiplied by c, which is positive 6. Now we're going to say negative 5 squared is positive 25, negative 4 times 1 is negative 4, negative 4 times positive 6 is negative 24. Again, we're still getting the discriminant is equal to 1. And because we have actually previously said that 1 is a perfect square, means that the discriminant is equal to a perfect square, that means that this expression can be factorized. Let us run an example. So let us say maybe we have something like 4x squared minus 3x plus 5, just for an example, right? So let us check if this one can be factorized or not. Remember that we have something like this. M squared minus 5m plus 6 is equal to 0. We have to check if it can be factorized or not. If it can be factorized, then we're going to factorize it, and then we're going to apply the zero identity factor, and then solve for m or x as we did in the first example, right? So now we have something like this. Let us check if 4x squared minus 3x plus 5 can be factorized or not. So we're going to say this discriminant is equal to b squared minus 4ac, which is equal to b is negative 3, a is positive 4, c is positive 5. So b is negative 3 and then squared minus 4 into a, which is positive 4, multiplied by c, which is positive 5. So now negative 3 squared is positive 9. Negative 4 times 4 is negative 16. Negative 16 times 5 is negative 80. So we have negative 80. Now the discriminant is equal to negative 71. So the fact that the discriminant is negative, it is less than 0, and it is neither equal to 0 nor a perfect square means that this expression cannot be factorized. So this is how we check the factorizability of an expression or an equation. That means that for this one, we're going to have to utilize the quadratic formula. But the fact that it is negative, that means that we're still not going to get any factors, even if we utilize the quadratic formula, because it is negative anyway. The discriminant is less than 0. The discriminant must not be less than 0, because if it is less than 0, then we're not going to have any real roots. I hope that is clear. Alright, so let us run that example. I just needed to actually put this in your head that this is how we check the factorizability of an expression or an equation. So another example is maybe, let us say 3x squared minus 2x, let us say plus 1, something like this, right? So we're going to say the discriminant is equal to b squared minus 4ac, which is equal to b is negative 2. So negative 2 squared minus 4 into a, which is 3, multiplied by 1, which is c. So now negative 2 squared is positive 4. Negative 3 times, negative 4 times 3 is negative 12. Negative 12 times 1 is negative 12. Now the discriminant is equal to 4 minus 12, which is negative 8. So the fact that the discriminant is negative again means that it is neither equal to 0 nor a perfect square, and this expression cannot be factorized. One more example. Last one for the video. So let us say maybe we have something like, let us say, maybe, okay, let me just say something like 2x squared minus, let me say, 5x. I just want to become so accurate so that I don't actually become biased, because here we've actually got a negative number, here we've got 1, so it doesn't actually seem convincing or interesting. I want to make it a little bit interesting, so I want this example to be a little bit interesting also. So let me just find a convenient example. Alright, so let me rather say minus 9x instead. So let me say minus 9 and then plus 4. Let me say this. Right. So we're going to say this is equal to 0, of course, and then we're going to check if this can be factorized or not. So we're going to say the discriminant is equal to b squared minus 4ac. So it must equal to 0 or a perfect square for us to tell that this can be factorized or not, right? So b is negative 9, as you can see here. So negative 9 and then squared minus 4 into a. Let me shift a little bit to the left. A, which is 2 here, and then c, which is positive 4. So negative 9 squared is 81, and then minus 4 times 2 is 8. 8 times 4 is 32. And then now what is 81 minus 32? Well, it is equal to 49, right? So the discriminant is equal to 49. So is 49 a perfect square? Yes, it is a perfect square. So the fact that the discriminant is equal to a perfect square means that this can be factorized, okay? So this is how we check if an expression or an equation can be factorized or not. So now that we know that an expression can be factorized, we're going to factorize it. So for those ones that can be factorized, we're going to factorize them. But those ones that we cannot factorize, we're going to utilize a quadratic formula, right? So I hope that this video has been actually helpful to help you check if an expression can be factorized or not. So from here, now that we know how to check if an expression can be factorized or not, we're going to now get into solving for x. Alright, so I'm going to see you in the next video where we're going to be solving for x for different types of equations. See you in the next video.